Let's go. Okay, so hi everybody. I'm Damien, and I'm supposed to be a security specialist, and we are going to show you something called Harry Security.
Yes, my name is Romain. I'm working for Red Hat. I'm supposed to be a Java expert, and I know even less stuff about security.
And together, so we are going to talk about security and how to integrate it in your deployment process.
So the first thing is that, that would be weird. The first thing is that security is broad. So like, where do we start?
Okay, so the first thing to start with is what Microsoft did, in fact, and the OWASP project. It's pretty nice.
For one, they did. So okay, so it's called OWASP and threat modeling. That looked very cool to put on a resume, but what it's about?
It's kind of framework or a list of things that you have to consider if you want to put some security in your application, you know.
So, like, you know, it's going to allow you to like describe your system and like reduce it in small modules, something a bit more manageable, basically. It's what you're telling me.
Yeah, and then perhaps you can fit it into your sprints and manage it, and it should support you in fact in your quest for the full company.
Okay, it sounds less bullshit than I was expecting, so let's look at that in detail. So interesting. Where do we start with this thing?
We start with Stride and Dread. So first, Stride. So the goal is to put a category on the threat that you are facing.
Okay, so there is like 5 of them or whatever. We have no time to cover that, so just like, you know, let's pick one and analyze one just to have an idea. What is reputation? What is this R standing for?
The reputation is to prove that someone did something for real, or at least the user did.
Okay, and how this process is helping you mitigate that or fix this issue?
In fact, you have to rely on audit trails, and here you can really prove that at least this logging performed the actions. It can't be repudiated.
Okay, so now let's look at the other acronym, because there was 2 of them, remember?
Yeah, Dread. So here the goal is to put a priority or damage on your threat.
Okay, and by damage, what you mean here is actually the impact on my business, not damage in general.
Exactly.
Yeah, let's go quickly over the other part of the acronym. So what is this reproducibility?
It's how easy to reproduce the attack. Come on.
Yes, and exploitability?
Well, how easy to reuse and make something nasty with this attack?
Well, affected user, I guess this is transparent, but still.
Yeah, well, are you impacting 50% of your users? All your users? Only 1% of your users?
Yeah, only the admin, basically. Discoverability.
So here it's important. It's how it is for a complete noob at the other end of the world to discover again the threat or to exploit it. So globally, the system is just for having the priority and knowing how damageable it is.
Okay, so I kind of like it because what I really like here is that it's a brilliant tool to communicate. So you can have your low-level grunt guy doing like very hardcore security stuff, being able to communicate to his top manager wearing a suit. This is a real issue because they have a way to communicate. I like that. It's kind of UML for security.
Well,
if you like UML. Okay, let's make it a bit more concrete now. We're going to think about a simple web app. Like, we're not going to think like a big application, something very simple, something like, you know.
Yeah, so a stupid web app, what we call really stupid, like just a WAR file, for the example.
And to make it even more simple, we're going to take an internal app. So it's not going to be like, it's going to be an internal app for employee. It's going to be not sexy, nothing fancy, no high frequency trading, no big data, no Hadoop, no machine learning, not even social app.
Yeah, so let's call it a cool app.
Yeah, hashtag cool app, exactly. So let's discuss how we're going to build it a bit. So it's a Java application, right? So we need to have frameworks. Like we actually need to hibernate the shit out of our play framework. And of course, we have to build it with Gradle because Maven is for loser and stuff. The good thing about this tendency is that there is framework for security, like there is for everything else in Java. So let's take one of them and look at what it does.
Yeah, cool. I don't know Java.
I'm working for Red Hat. This is actually painful to do that. Anyway, you don't know anything about Java, so I'm going to explain you what this shit is doing.
Please do.
Well, actually, it's quite appealing. It brings a whole stack of security pampering into your application, basically giving you all the stuff you need to have like authentication, authorization, saying that this user is able to access this part of the resources and stuff like that.
Yeah, but here you are talking about only your application. So if I think about an attack as admin or security guy, my first idea is the man-in-the-middle attack.
Well, the framework support that. It comes with support for HSTS and also ensure that your client is using HTTPS.
Yeah, okay, so if we go directly on the front end, so for click checking?
Also support for that. You can use this frame option, .same origin thing inside the framework to prevent you for that. I'm not an expert on this part.
And for cross-site scripting attacks?
It also does that. It provides support for CRSF token, for instance.
Yeah, okay, and now if I want my audit logs?
Well, actually, we need that. We mentioned earlier we need that. And actually, it's also providing everything you need to have to do an audit log, an audit trail. So bottom line is, like we listed a long series of threats that are going to be a menace, like a danger for your application. And you need, given the amount of stuff you have to face, you need a framework to help you cover all your bases. That being said, we are dealing with an internal app, so we are behind firewalls inside a very compartmented VLAN, so we should be kind of safe, no?
Yeah, but come on, be serious, okay? So, you know, like most of they are using laptops and desktop to access the app, so basically there's at least one which has a root access on it, so we can consider that it's unmanaged with a nice malware on it.
Well, I have a good news for you. It's not even a laptop, it's tablet on mobile. So it's even better, you know. It's even less managed.
Yeah, it's called Bring Your Own Device, which is also called Bring Your Own Disaster. So to sum up, in fact, so we have a bunch of users with completely unmanaged devices.
And those devices all use the internet, which basically means that if somebody hacks your tablet, you're getting directly access to the internal app, the one hidden behind layer of firewall. You're just one tiny hop from the internet.
Yeah, but you said it. We have firewalls, come on.
Well, yeah, so this is a misconception. Firewalls are not about security. Firewalls are about network quality services. That's what they're doing, actually.
Yeah, you have to explain this to me. I'm a security, you know, so I love firewalls.
Of course you should, but it's not really helping you in this case, because firewalls are designed to block ports, right?
True.
And generally, you're blocking ports that are not used.
True.
So you need to use the port for the application.
Yeah, okay, I can't close all ports, of course. Yeah, okay, so the application has to be reachable at the end.
So the attack is going to follow the same path as a regular user, so you can't block it. So yeah, that's the issue with firewall.
Okay, so what should I do then?
Well, the real trick here is to analyze and monitor the traffic itself and the content of it. For instance, if your application is supposed to send an email using SMTP, this is the only thing you should be allowing there, and it should be valid SMTP. So that's the thing. Side note, both of us used to be consultants. We used to be traveling around like to different customers. So we've seen a lot of companies with different security settings, with different habits, and we used to grade how crappy the security is by the number of ports being closed.
It's just nice when you want to access your mails, you know, to help your customer, and no mails forbidden.
Bad.
And yeah, just for security reason, you know, the VPN you need to access to your support, in fact, to support your customer, well, is also forbidden for good reasons.
Yeah, that's very bad because, especially in my case, as a Red Hat employee and consultant, if I go to a customer and I contact my VPN, I can't do anything for you anyway.
And what I love is, in fact, the use case where, in fact, there's only one trusted user by the customer who has access via SSH to the machine, but not you. You are supposed to help him, but you don't have access to anything.
So generally, it goes in, is log in, and you piggyback on his SSH connection, and you connect to the system anyway. Useless. Don't laugh. I've done that.
We did it. And, well, so at the end, it's nice to block ports and so on, but it's mostly about illusion of security, okay?
Exactly. We gave a very strong illusion of security because everything is blocked, so everybody's work on a daily basis is shitty, but there is no real security.
What is important here, jokes apart, is so you keep an eye on the protocols and you filter the contents.
So generally use that for this kind of stuff. Where are we now?
The notes?
Yeah. So it's actually quite nice because if you do filter the content and if you do implement, like, if you drop invalid request, on the other hand, as a Java developer, the amount of hacking you must be facing are far more reduced. You just need to face potential hack based on the regular behavior of your application. You're not going to get some kind of crazy URL with like buffer overflow or whatever because the reverse proxy is going to drop that.
Yeah, okay, so let's go on another area of the application.
Yeah.
You have the application, but of course also you have the data. And in our use case, we have no real business. It's just an old app, so there's no real user, and it's not even interesting. So it's not about wire transfer or whatever. No value to hack and sell somewhere else.
Yes, you won't be stealing our money to put it on the dark web. This is an internal app. However, we do have like typical, employee productivity data. So stuff such as employee address, phone number.
Yeah, so what is called, in fact, personally identifiable information. And by law, you have to take care of those.
So also you may have salaries, financial packages passing on the wire.
So of course, here you have to restrict access based on the user now.
And there is always a bit of business in this kind of stuff. So you may have information about deal, opportunities.
Yeah, this is confidential. So even if it's just a stupid app, we have to secure it.
And by secure, it means encrypting everything from one end to the other end.
Yeah, so encryption, okay, on the front-end side. So if we want to encrypt something, we have to encrypt first the communication. So it's SL and HTTPS.
Exactly. So that's pretty easy. I think everybody here has ever deployed HTTPS or SSL on his own little Nginx or Java web. It's like 10 minutes to do this. Keeping it safe, keeping it keep running and a bit that sort of work.
It's heavy. It's massive, in fact, because it's an operation that you have to remember how to do it. It's crappy most of the time. And you can do it only once a year. And if you fuck up, in fact, at the end, all your user will be kind of rejected by the security, of course. And I'm not even talking about a leak certificate, which is then still valid, but, well, you shouldn't use it.
Yeah. So let's imagine right now that the infrastructure is correct and we have done that. Well, we are good, right? We have SSL in place.
Yeah, nobody moved, and in fact, so, but SSL has been now, it's TLS, so yeah, you still have to keep up your knowledge.
That's exactly the point here. So we've dealt with the front end. Let's look at the back end now. Well, before that. So now we also have to encrypt everything between the app and the databases, because this could also be spied on by hacker. And that's actually complicated because, databases are not very good with.
No, yeah, so we have a bad experience with also MongoDB, for example. It's really hard to have and to maintain encryption of data. And in the case of MongoDB, well, the feature was missing for years.
Yes, I remember that actually the first version of this talk, my coworker François, my former coworker François, had to basically implement that in MongoDB. So, or backport it in MongoDB. Anyway, let's say that we have secured this part. There is still one little detail. Database is running on a physical system, on virtualizer one, and it's storing on the disk. Hacker can also access that. So you need to think about, do I need to encrypt my data on it?
Yeah, well, of course, yes, come on. But by saying that, I'm not solving the problem, because encrypted everything is pretty heavy. It's expensive in terms of cost, well, money or performances. And encrypting everything, in fact, doesn't really help, especially when you select what you want to encrypt, and it's not the good data.
Yeah, so you may remember this story about Ashley Madison last year. It's a perfect example of that. Basically, they did everything by the book. They did encrypt the password, for instance. There was Ashley password, but they did not encrypt the name of the user, neither the email, neither the physical addresses. So you had everything you needed to blackmail people. People committed suicide because of this hack.
Yeah, this can escalate pretty fast.
Yeah, that went dark, but yeah. So, point being that now we have encrypted everything, so we need still to access it. So we need to have legitimate user access the application. How do we implement that?
Yeah, well, we have to prove who they are and ensure who they are. So it's called strong authentication nowadays.
Exactly. So the thing is that you cannot just use the same password. You need to have more, because or simple password or even
yeah, LDAP, Kerberos, it's not enough.
So this is why you can't have a simple password, and also because all passwords can be stolen. So anyway, you talk about something called 2FA, I think. What is this thing?
Yeah, so two-factor authentication. So to authentify someone, you have three-factor authentication. Who the user is, so it's a biological, well, a fingerprint, for example, what the user knows, like a password, or what the user has, which can be a mobile phone or a security token, for example. And two-factor authentication is, well, you pick 2 out of 3.
Well, second, 2FA is definitely the best way right now to implement strong authentication, but it has a big issue with it, is that people don't like to always put out their phone to take a token or have a token. Users generally fight it and complaining quite rightly. This is harming their productivity.
Yeah, so if you want to have 2FA, you need definitely to have SSO, a single sign-on process. Otherwise, well, the user will be your enemy at the end.
Yeah, so for instance, in Red Hat, I'm pretty lucky because when every morning I'm logging in my email and I get access to the wiki also, I don't need to relog all the time. Well, not that much, at least. Up to you.
Yeah, so what is really important is that the security is not an excuse for the user experience. The good example here is, in fact, Slack, for example. Nowadays, we don't even need a password, and it's still safe to log in. The user experience is just brilliant here.
Okay, so let's go back to our app. We have it secure. We put every encryption everywhere. We're good, except that recently, if you pay attention, the scope of the battlefield for security has kind of extended because there is other way to harm your app apart from actually exploiting a defect. For instance, you can hack it at the source and hack your CI.
Yeah, so the CI is also a very sensible system. In fact, it's a system which has a lot of power. For example, it has the rights to download your dependencies. It has the right also to access production, because when it is triggering a deployment, this is what he's doing, and he's doing on something that he has built.
So if CI is accessing production, CIs have your secrets, which means that you need to handle and manage your secret properly. This slide is difficult to read, but this guy committed password into his GitHub. So guess what happened? So that's complex. You need a tool for that. People are generally using something like Ansible Vault to do that.
This is what we try to do, in fact. But the secrets are not the only weakness in the end.
Yes, because if you're doing things right, hopefully I wish for you, when you're building your app is 95% not your code. It's dependencies fetching from everywhere. Especially if you're doing Java, you're going to fetch Apache command lines, Apache whatever, Wildfire Blast, Spring Boot Thingy. So, and when you're fetching stuff from everywhere, it's from the internet. So you are basically implicitly trusting the internet there.
So it's definitely not funny here, but you have to download carefully your dependency. You have to check what you are downloading, and just check the checksums. Okay, it helps.
Exactly. So by the way, Red Hat have been pushing this model for years with satellite. Already with RPM, way before we bought JBoss, we were already pushing people to say like, have a repo, sign everything, know what you're handling.
Yeah, you already focus on Red Hat, don't you? But well, at the end, manage your artifacts.
They do pay my bill, you know. Okay, so application is built, CI is somehow safe. So now we have a nice little war. Let's run it, let's deploy it.
Yeah, just tell me where.
Yeah, I don't want to deal with this shit. I'm too old for that. I'm going to do what the cookies are doing. I'm going to go cloud native.
So in fact, you don't trust the internet, but you trust someone else's computer.
Well, I actually believe that cloud is safer than in-house server.
Whoa, really?
Well, if you're running on the cloud, you do have to rebuild your images on a regular basis. You have to push new stuff. They're going to be crashed and removed. So you kind of have to keep it fresh.
Yeah, okay. That's true that we have some servers at home, and well, they're still not patched. Okay, point taken.
Yeah, it's been 10 years, that is so. Also, like, if you look at Netflix, for instance, Netflix has a very cool model, and if you access a movie this weekend, the VM you're going to run on is at worst 2 days old. At worst.
Well, it's just nice, but even the problem is, even with a fresh system, sometimes, well, with 0 days, the system is still sensible to attacks. For example, Meltdown hasn't been fixed for days, weeks.
Yes, and this is bringing us to the very next point, and the most important point is that security is not about being, patched and, fresh. It also needs new guys to be ready to fight and attack actively. So let's take an example. Do you remember a few years ago when GitHub was attacked? GitHub faced a very strong distributed denial of services attack, I think 2 years ago now. And they were very communicative about that. They were saying on Twitter, hey, we're under attack, so the site is off, we're doing that, we hope to be able to blah. And they were very efficient about that. And that was very interesting to see that they were both, able to patch the system, but also actively resist an attack. And they were very transparent also.
Yeah, what is really important is that your business is not an excuse for not being transparent to your customer. So, hey, this is my turn. So I'm working for a bank, which is a startup, and we have, even for a bank, we have a status page where we show the state of our system. We are transparent for our customer, so in case of storm, well, we hope they trust us a bit more.
Yes, if you have, if you remember Equifax last year, this is a mess by hiding these leaks they were having. For weeks they didn't say anything, people were in danger, and they should have really much come forward and tell, hey, we've been hacked, like be safe about that.
Yeah, they try to run away from them responsibilities and in fact endangers way more in fact than customers. They even hide details for fixing in fact the breach.
Yeah. So the point here is actually that it's not a question of are you going to be hacked, it's the question of when are you going to be hacked and what you're going to do at this point.
So let's take the metaphor of firefighters, you know. Firefighters, for example, are always trained to fight, well, fire. So in fact, you have to be trained to face an attack.
Exactly. So basically your app is bound to be hacked at some point. So you have to prepare for that. So to go along with the firefighter analogy, if you want to protect a building against fire, you're going to first install, for instance, like smoke detector.
Which in IT sense is more IDS, so intrusion detection or prevention system.
You also need to have like fire doors to stop the fire to grow in the building.
Yeah, and for your Red Hat approach, it would be SE Linux.
Yes, exactly. And everybody is running with SE Linux here. Yeah. And of course, we're doing Java, so you're all running with the security manager on, no?
Wait, everybody is doing containers nowadays, and I'm sure they care about that SecCom profile.
Yeah. Point taken. Anyway, let's time to wrap up and sum up what we've been rambling for 20 minutes. So last slide. So, yeah, I survived. You first.
Yeah, so what is really important for security is to keep in mind the big picture, to not lie to yourself, in fact. You have to analyze your risk in order to at least know where you are and where you stand, in fact, with your little application.
And don't ever think you're safe. You can always be hacked from somewhere.
Yeah, VLANs and firewall are just an excuse. Come on, no, there's no real defense.
And your data isn't safe either.
You have to encrypt what needs to be encrypted. This is the hard part.
Yeah, and encryption means managing secrets and using strong authentication.
Which doesn't mean that, in fact, you have to forget usability to face security. There's no trade-offs here.
Yes, and also don't forget that the battlefield has extended up to CI and cloud and other environment.
So you have to also take care, as part of your application, the continuous integration system, how you deliver code and how you deploy, even in the cloud.
So basically, finally, be ready to fight fire, in this case an hack, because you are going to be hacked.
And that's it.